Hello my dear friends, welcome back. I hope that you've liked the previous video where we have done the first question based on two algebraic identities. So today we are going to continue from there again. I left this question 2 for this video so that maybe we can do a little bit of revision from what we learned in the last class. Okay, so let's get straight to the question. That is, of course, yes, today we'll be learning one more new identity. Okay. Evaluate the following products without multiplying directly. That is what the question says, without multiplying directly. So the question is 103 into 107 into, but you're not supposed to multiply directly. And that means what? You cannot multiply directly. That means we have to use or take the help of an identity. Remember that identity? What was that identity? Those two identities that we discussed last class? Yes, it was x plus a into x plus b was x squared plus a plus b into x plus ab. So if you have not watched the previous video, please go back and do watch after this video. Maybe do watch the previous video also. So we'll try to do that. So now, but remember, the more number of zeros we have, the easier it becomes to multiply. So we're trying to keep the problem simple, okay, not complicate. 103 nearest to 100. We'll try to use a value that is always nearer to a 0. Preferably 100 always, or 1000 or 10, multiples of 10. So 103, you see we can write it as 100 plus 3. 107, we can write it as 100 plus 7. So if you remember last video, I told you that this formula is just a model only. We are just, if you want to use it, we can use it if whatever problem that we're solving fits into the model. If you remember last class we did that. So now if you compare this, what happens here? X is like 100 now, because now x, see we can compare, isn't it? X is 100, 100. A value is 3, B value is 7. So we'll just use that formula then very easily. That is 100. Okay, let me just write on the formula here. X squared plus A plus B x, don't write this one for you, a into b. Now look, everything is same, right? So x, what is the value of x here? 100. What is the value of a? 3. Value of b? 7. Value of x? 100. Again, a into b, a is 3, b is 7. But you just have to do that only, nothing much. So that will be 1, 2. Square means double, no? 1, 2, 3, 4 plus 7 plus 3, 10 into 100. Always use brackets as I have told every now and then, 21. So that will give us the value 1, 2, 3, 4 plus 1, 2, 3 plus 21. So that's going to be 1, 1, 0, 2, 1. Just adding it, 1, 1, 0, 2. Alright, okay, now the next question, that is 95 into 96. That is question number 2. 95 into 96. So this is also almost the same, but yeah, subtraction, because nearest to 100. So 95 into 96, see, we can write it as, of course you can write it as 90 plus, that is also possible, 90 plus 5 into 90 plus 6, because nobody has given a fixed rule that you will always have to use x only, 100 only. No, absolutely not. We can use 90 also, 90 plus 5 into 90 plus 6. It's just that 90 square, if you can, no problem. 81,000, if you can, no problem. 8,100 I mean. But yeah, we will prefer, it's just that no, we will do with 100, because getting multiples of 100 is always easier for us, so that's why. Okay, but yeah, you can do it with other values also. It's just that we have to use, like, what are we supposed to do here with this question? We will not be you are not allowed to multiply directly, bus. So we'll use some of the identities and multiply. Simple as that. Not that every time you'll have to take 100 and this and that. No. You can do it in your own ways, okay? Don't worry about that. You can use your own imagination also, provided, yes, the conditions are kept intact. So now you see what happens here. Last video we have solved some problems like this. Here what happens, x value is 100, a value is -5, b value is -4. So I'll write down the formula once again, x square plus a plus b into x plus a into b. So I'll just substitute the value of x. What is the value of x here? 100 square. This is just for your understanding. A value -5 plus b value -4. So in that case I will use the second bracket now, into 100 plus a into b. So I'll have to rub this off. Plus a -5 into b -4. No? So that's 1, 2, 3, 4 plus -5 -4. Okay, into 100, it's all the same. Plus 5 4s are 20, minus into minus, plus 20. So that's like 1, 0, 0, 0 plus -9 into 100 plus 20. So it's like 1, 2, 3, 4 minus 900 plus 20. So that if we add this 1, 0, 0, this first and last minus 900. So we can just subtract this 1, 0, 0, 2, 0, 900, 0, 2, 10, 1, 9. So that will be 9120. 9120. Alright, okay, I'm rubbing it off. You can pause the video and complete also if you haven't. The last one. (104 into 96). So let's do this quickly. 100 plus 4 into 100 minus 4. 100 plus 4 into 100 minus 4. Yes, of course we can use the formula that we have just used in the last the number 1 and number 2. But if there are other identities, easier identities, then we will use that. Nobody has told, no, you have to use that identity, no. Is it given there? No. Question is just find the product without multiplying. How? That depends on us. So you are free to use any of the identities. So we have a wonderful identity again. That second one. What was that? X plus a into x minus a. Remember? X square minus a square or something like that. What did I think x plus y. I forgot. Of course letters don't, it's alright. Letters don't, values will change. So I think it was x plus y into x minus y equal to x square minus y square. And a plus b into a minus b equal to a square minus b square also. Forget about the letters. So if you look here, see 100, 100, 4, 4. Every term same, only plus and minus different. So that is simply x square minus y square. So that's 1, 2, 3, 4 minus 16. 4, 9984. 9984. Simple as that. Simple as that. Simple as that. Alright, chalo. You could have done using that first identity also, no problem, okay? Next question number 3. Factorize. Factorize. Remember, factorize means find the factors, no? Factorize the following using appropriate identities. Factorize the following using appropriate identity. Factorize using the following appropriate identities. So before you really begin, 1, 2. I think last class we did two identities. Here we will use another 2 more identities. A plus B whole square formula, complete square formula, this one. A very important, this one also, A minus B whole square. Every terms are, of course these are not new formulas, so this is completely not going to be like wow, new and all. Yeah, we have already done that. We have already done this, something like a revision only, no? So A square plus twice into A into B plus B square, and this one, every term same, just here middle 2AB. For plus it's plus, for minus it's minus. The rest of the terms are same, so it's easy to remember that way also. All the terms are same, A square plus B square plus twice AB. Here also same, just for plus it's plus 2AB, for minus it's minus 2AB, only for whole square. That's why it's called complete square formula. Now, for the first question, 9x squared plus 6xy plus y square. So if you look at this formula, I mean this product is not in this form. I'll rub this part, okay? Just no distractions. So, this formula is not written in this form. In fact, it is written in the other form. Of course, we can't say. Maybe some other identity also, but it looks like that. It looks like that. No? 3 terms, 1, 2, 3, xy is also there. Can we convert it in this format? So that, can we just modify it properly, arrange it so that we can convert it in this format and then we can factorize or find the factors? Let's see. What do we need? We need a square, something whole square, a square. See, 9x square. 3 square is 9, x square is x. Can we write this as 3x whole square? We need something whole solid square, okay, not separately. No? No problem. This one, let's leave it. 2 into A into B. We don't know, let's leave that. Plus y whole square. That is possible. Now let's see whether it fits in or not. So it's like a square, b square, then we should have 2. A into b. What was our prescribed, assumed a, not assumed, our modified a, 3x. Let's try to just put it here. This one, b, y. Now you see, 2 3s are 6, no? 2 3s are 6, x, y. You see, its middle term is 6x squared, x, y. First term is 9x squared, 3x whole square, y square. Now you see, this one looks completely like this format, isn't it? A square plus twice of a into b plus b square, isn't it? Then definitely this we can write as a. What is the value of a? As I again repeat, those formulas are just models. Not necessary every time it has to be a single term only. No, as long as it fits in the model, that is enough for us. So a value is 3x plus, because it's plus, the middle term is plus b whole square. A plus b whole square. So that means this can be written as whole square, so 2 times 3x plus y into 3x plus y. So we have our factors here, 2 factors here, 3x plus y and of course 3x plus y. Factorize means that only. Alright? Okay, for the second question, we are going to need that difference one. That's the second formula, that is a minus b whole square. So what was the formula? Everything almost remains the same, just that the middle term is like minus. So for the second question is 4y square minus 4y plus 1. Simply expansion is fine, but this time we are trying to go reverse. Now from here we will we will like try to see whether it is in that form, this where a, b, c, a, b, all the terms are completely perfect, balanced, satisfied. If yes, then yeah, we will reverse back to this format, complete the square formula. Let's see. Is it possible? We don't know. Let's see. 4y whole square, perfect square. So 4y square can be write as 2y whole square. Whole square, because 2 square is 4, y square is y. For example, 7x square. See, 7x square, definitely I can write it as 7x whole square. So maybe in this kind of problems, okay, we'll have to think and find out some other ways to do. Alright, or root 7x square and all. Alright, so that's what it means. That's what I mean. But this one we can write 2y whole square minus, it should be 2 into a into b. A and b we still haven't decided. So let's see. Of course, a we have already decided, 2y. Plus b square. B square 1. 1, of course 1 we can write as 1 square. So the value of a is 2y, b is 1. So twice into a into b. But we have to check, of course, okay, we have to check. 2 2's are 4y, see, and check with the middle term. So you see, this product 2 2's are, 4, we've just expanded it, like arranged properly. So 2 2's are 4y, perfectly sitting there. So that means this is of the form a square minus twice into a into b plus b square. That means we can write this as a minus b whole square, because middle term is minus. And this, of course, in terms of factors, 2y minus 1 into 2y minus 1. Another question, last question. Here, if you remember, just now recently we have done this question. Every time we are trying to like go backwards. Can we write that in that format? Definitely yes, because it's x square minus, remember, whole square, not one term or square, second term, the other term will not be, no, it has to be complete. But here no problem, because y square minus 10 we can simply write as y divided by 10 whole square, because y square is y square, 10 square is 100, it has to be whole square. Then in that case the value of, so it's in this format, x square minus y square. So what shall we do? It is x plus y, that is x plus, what is the value of y here? Y by 10, x plus y into x minus 1. Simple as that, x plus y into x minus 1. Alright, so definitely, of course, yes, these are not new terms, more like revision only. Okay, so yeah, that's it. So these are the two more identities. So far we have done like 4 identities. So in the next video, next session again, we will be doing with the another 1 or 2 more identities, which we will try to solve again. Okay, so I hope you've liked the video. If you've liked the video, please do give me a like also. So alright, then I'll see you in the next video with the other revision, other identities. Okay, so fine then, see you. Please stay safe. Take care also. Bye bye.